Okay, so related rates, problem number 3. So, while working at a factory, you notice that a large cylindrical container with a radius of 20 meters may be leaking a toxic substance. You notice that the height of the liquid is decreasing at about 10 meters per minute. What is the rate in cubic meters per minute that the container is leaking? Okay, so we're going to start off with the equation that we're dealing with. So, the volume of the tank is going to equal pi r squared times h. Okay. And so, first, a bit of information that we are given in this problem is the radius. So, the radius is going to equal 20 meters. Okay. Okay, you notice that the height of the liquid is decreasing at about 10 meters per minute. So, what is that giving us? That giving us that dH dt is going to equal, as is going to be 10 meters per minute. Okay? So, all right, so we're going to take the equation that we're dealing with, which is the volume which equals pi r squared h, and we're going to differentiate both sides. But the last part of the question says, what is the rate of the volume in cubic meters? How is that changing? Well, that's saying dV dt, that's what we're going to be looking for. So, now let's differentiate both sides of this problem. So I'm going to take the derivative with respect to time, and I'm going to have it act upon the left and the right hand side. Okay. Now, when taking this derivative, we're not going to take the derivative of the radius with respect to time because the tank, its radius is not changing. The only thing that's changing inside of the tank is the height of the liquid. So, this means that dV dt is going to equal pi. All right, we're not going to mess with the r because the radius is not changing. However, the height of the fluid is changing. Okay. All right. So this gives us that the changing of the volume with respect to time is going to equal pi. All right. Now the radius, which is 20, and that gets squared, and then the h dt, the height is decreasing, so that's a negative 10. Remember, if it's decreasing, it's negative. If it's increasing, it's positive. So we have to include that negative right there. All right. So, all right, at this point of the problem, this is going to be multiplied by negative 10. Okay? So this is going to be negative pi times 4,000. Okay, and now this is going to be meters cubed per minute. And so that is how much of the liquid is actually leaking out of the bottom of the tank per minute.